For topic 2, we're going to cover the second exponent rule for multiplication, which is called the power rule for exponents. So this one states that when an exponential expression is raised to a power, what that means right there is you already have an exponential expression. So that means you already have a base and an exponent, but then that expression itself is raised to an additional power. So you kind of have like this double exponent thing happening. When that happens, we keep the initial base and we multiply the exponents. So symbolically, if we have b to the m, that's our initial exponential expression. And then that is raised to the n power. We keep the base of b, and then we multiply the m and the n. So let's say we have x squared times x. Well, I was about to do the product rule, hold tight. Let's say we have x squared cubed. That means we have x squared times itself 3 times, which means we really have x times itself twice, 3 different times, which is really, if you look right here, 6 x's. Well, how could we get that 6? Instead, we could just say, well, this is x to the 2 times 3 power, which is x to the 6th. So we save ourselves all that work of like writing things out, which is especially nice if you get some larger exponents, okay? So again, when you have an exponential expression raised to an additional power, you keep the base and you multiply your exponents, okay? So this time we have 2 to the 3rd squared. Well, this is going to be 2 to the 3 times 2 power, which is going to be 2 to the 6th. And just like in the previous example, when we're dealing with a base that's a number, let's go ahead and just evaluate it out. Let's multiply it all the way out. So let's go to the calculator. So here we have 2 to the 6th power. So again, we want to type in our base, which is 2. We want to use that caret button, which is above the division symbol. And then we want to type in the exponent of 6, and that tells us we get 64. And just to prove it to ourselves, let's go ahead and multiply it out. 2 times 2 times 2 again, times 2 again, times 2 again, times 2 again is 2 to the is 64. You could also do 2, let me do parentheses actually. So we could have in parentheses 2 to the 3rd. And then we could raise that to the 2nd power and we'll still get 64. Okay, so just make sure you understand how this property or this exponent rule works. Very similar in idea for students to the product rule. What you're doing is completely different, but students tend to get this one and the product rule mixed up. So really understand the difference between these two rules. Okay, so let's go ahead and look at the last two examples. So we're still just going to use the power rule here. So for part B, I have x to the 5th to the 7th power. Now, this is not one I would want to write out because I'd have to do x to the 5th 7 times. Well, that's 5 x's, 7 different times. So that ends up being kind of cumbersome to write out. That's the power of these rules, or the nice reason we use these rules, I guess is what I should say. Okay, it just saves us a lot of energy. So we're going to keep the initial base. We're going to take the exponents. We're going to multiply them. So we just get x to the 35th power. And again, what's really happening is we have x to the 5th 7 times, which is 5 x's 7 different times, which does end up being 35 x's, but I wouldn't want to have to write that out. So using this product rule or the power rule, either of them, they just save us some time, okay? Last up, we have z to the 3rd to the 6th power. Well, that is just going to equal z to the 3 times 6 power, which is z to the 18th. Okay, so the big thing here, I don't think the power rule or the product rule individually are difficult at all. They're quite simple. They save us some time. They're easy to understand. You add exponents, you multiply exponents. The hard part is sometimes we want to confuse them and we want to do them backwards. So really, the issue here is making sure you understand which is which and when you add your exponents versus when you multiply your exponents. Okay.